And then we made another breakthrough discovery, and that is that serverless is a big deal. If we're going to be the dominant default cloud service for Postgres, the underlying technology needs to basically be endorsed and blessed by Postgres itself. Obviously, owning Postgres is impossible. That cat's out of the bag. It's like owning Linux. But you can build a company that is providing the best Postgres service in the cloud. That's where the most valuable workloads are living anyway.
Hey, this is Brian, and you're listening to Jamstack Radio, a bi-weekly series where we discuss modern web development with maintainers, founders, and developers. Jamstack Radio is brought to you by Heavybit, the leading investor and developer-first startups. For more information, visit heavybit.com. If you're interested in being a guest on the show, or if you'd like to suggest a topic, find us on Twitter at Jamstack Radio. Welcome to another installment of Jamstack Radio. On the line, we got Nikita Shamgunov. How you doing?
Great. Very happy to be here.
Excellent. Yeah. So I'm actually happy to have you here. I've been following Neon for a bit and looking forward to digging into serverless Postgres. But do you want to quickly explain who you are, what you do at Neon?
Absolutely. So I'm CEO at Neon. Neon is a company that is 2 years old and change, maybe 2 years old in a couple of months. And we're building serverless Postgres. Now, I spent my whole career in the database space. After my PhD, I started in 2005 working on the SQL Server project at Microsoft. After that, after 6 years at SQL Server, where I worked on the core engine, mostly on the compute side of the things. So all databases, they typically have storage and compute. So I worked on the compute side of things. I started a company called SingleStore. SingleStore is a unicorn company as of last year. It raised, I believe, at 1.2 or 1.4 billion in valuation. So it's already post the crazy 2021 years. It was in 2022. So the valuation is more justified. And it's a scalable database. So I spent a decade building SingleStore from the ground up. And through that journey, we built a scalable database, which turned out to be an enterprise first offering. So basically, because it's scalable and can support very, very large workloads, you find those workloads in the enterprise. And the sales motion for this company turned out to be top-down enterprise sales motion. After that, I joined Khosla Ventures as a partner. And walking into Khosla Ventures, I spoke to Vinod Khosla, who basically is the founder of Khosla Ventures, and said, as I was building SingleStore, focusing in the top of the market, I have this idea of how to become kind of the default cloud database and go and figure out a bottoms-up adoption. And that was the idea of Neon. Vinod said, on the spot, here's $5 million. Why don't you figure that out? And we're going to incubate the company. And we started working on that. We started payroll on March 1st, 2021. And think about, when you start companies, typically it's a group of friends that are kind of iterating on the idea, figuring that out. In this particular case, this was a company built in a lab. So the idea was there. The idea was to create a dominant Postgres offering. We kind of observed the fact that Postgres is becoming more and more popular as a developer choice, and nobody owns Postgres, which at least from the very first principles allow you to come up with a company idea that provides the best Postgres service. Obviously, owning Postgres is impossible. That cat's out of the bag. It's like owning Linux. But you can build a company that is providing the best Postgres service in the cloud. That's where the most valuable workloads are living anyway. And so despite the fact that it was not very clear why Neon will win over RDS or AWS Aurora or, Azure SQL or Cloud SQL at Google, we felt that the opportunity is large enough to go and try. And we started with building a team because the company you build is the team you build. And so I started calling all the Postgres committers.
Okay.
I had a bit of a brand. Already, having built a database company, which is a unicorn company, and I was pitching that. And as I was pitching this, I was refining what we're actually going to do because people ask questions. So very quickly, we navigated to at least one important idea that, if you look around and see who is making money in the Postgres ecosystem, Mostly that's Amazon. Like that's probably number one. And Amazon is making money over the two products. One is RDS and the other one is AWS Aurora. Because I'm a database nerd, I intimately understood the architecture of AWS Aurora. In the database world, everybody knows that. It won 10-year award paper, and I believe in 2017 in one of the major database conferences. So, it wasn't a secret that this was at least a very exciting architecture. And also a bunch of time had passed since 2017, and people were also clear that, hey, you can improve this architecture, and call Aurora's architecture V1. There was a V2 and potentially V3. We actually managed to come up with a V3 of that architecture. And in databases and in systems in general, architecture is super valuable because if you set the architecture, everything layers on top and all the concepts you introduce in the architecture, they stay with you forever. So you got to get this one right. And we had a lot of conviction that if you want to build a modern, best-in-class cloud service, this will be the architecture. And the key in that architecture was storage. So at SQL Server, I worked on compute. At Single Store, we built the whole thing, storage, compute, cloud service. Here, the kernel of this is storage, but database storage, not file system storage. So that was kind of the first mega insight for us, that the key architectural advantage will be that storage. And we integrated that storage with S3 for cost reasons. And then we made a decision to open source that storage. So we said, if we're going to be the dominant default cloud service for Postgres, the underlying technology needs to basically be endorsed and blessed by Postgres itself. And it would be impossible if especially for a startup, Amazon maybe have a different type situation because of such a gigantic company. But for a startup, we got to be open source, and we claim that real estate of, open source alternative to Aurora. And we even positioned our storage initially in the GitHub repo as an alternative to AWS Aurora. We also decided to build it in Rust as opposed to C++, even though I grew up in C++, just because it's a modern systems language. It can allow to attract a modern systems developer. So we actually arrived to that relatively quickly and through the debate. And then we started writing code. In parallel, I've been calling Postgres committers, got blessed with two co-founders, Stas and Heikki, which are absolutely phenomenal. Heikki is a Postgres committer, Stas Postgres contributor. The difference is Heikki can author commits, and Stas needs to find a committer before commits go in. And we built our initial team around Postgres hackers and systems engineers. And then we made another breakthrough discovery, which became our positioning. And that is that serverless is a big deal. We realized that serverless is a big deal. And we also realized that is hella hard to build. And specifically, I'm very proud of the hella hard because I'm an immigrant and I learned it from South Park.
Well, you're in the Bay Area, so yeah, it's you're catching up quickly.
Yeah, catching up quickly. It's only been 18 years for me in the United States. So, so we discovered the serverless is important. We discovered it because early on, I called all the future ecosystem partners, including Guillermo Purcell. I was introduced to him by a common friend, Alad Gil. And that's what Guillermo told me, that serverless is important. I also knew that serverless really took off at Aurora. And then the third thing is nobody else has serverless. There's literally two serverless offerings for Postgres. One is Aurora and the other one is Neon. Nobody else can do this. And there's kind of now that we've sunk multiple years of R&D into this, it's pretty clear to me why. Because it truly is quite hard. And serverless, for something that was not designed to be serverless initially, requires a particular technical approach, which in our case is basically orchestrating micro VMs. So we run Postgres in micro VMs, we inflating and deflating them, and we live migrating them between hosts. And live migration doesn't even break the TCP connection to the VM. And so that kind of scheduling machinery operating on the fleet now over 100,000 databases is like a piece of art. And there aren't papers that you can read that describe you to how to do that. So it's kind of like a very hairy project that lives in the world between systems and just kind of plumbing things together and leveraging, micro VM orchestration and Kubernetes. So, but long story short, we discovered that serverless is mega important. In general, the fewer knobs you have to your system, the easier it is to scale, the easier it is to adopt. And so the vision is that every time you spin up a Postgres database on Neon, all it is a URL. And once you have the URL, which is a connection string, then your storage, your compute is scaled for you. And you are only charged for what you use. You only charge for the amount of storage that you consume and for the amount of compute you consume on a per second basis.
Yeah. You mentioned Guillermo in passing, Vercel. That's what sparked me to reach out to you, which is the launch of Vercel Postgres, which is you're sort of one of the launch partners with them. So because can you explain how you're able to launch alongside of Vercel and how the integration works?
Yeah, and I think serverless is the keys to the kingdom here. I'll speak about two things. And for one, we're actually getting a good amount of criticism, which is scaling to zero. And I'll explain what's the roadmap on that is. But basically, in order to integrate Neon into any other platform, all you need to do is to create a Neon account and then use an API to spin up and spin down databases. Now, in the world in which we're not serverless, we would have to expose a parameter, which is the size of the database, or probably two parameters, the size of compute and the size of storage. And as we expose those two parameters, every launch partner will have to introduce their own menu of various sizes, call it t-shirt sizes, for your environments. And introducing those sizes will inevitably lock ourselves into be very careful of how we change those sizes as well. Because let's say you have 20 partners and then every partner has a bunch of sizes. And now you're like, oh, those sizes are wrong. So now instead of, small, medium, and large, I want to change that to medium, large, and extra large, whatever that means. Now you go to 20 partners and you have a conversation, and then they have their customers and they have to explain this to their customers, to their users. So that makes it just very, very tricky to operate. The other thing is Vercel has edge functions, serverless functions, and they kind of require the rest of the infrastructure to be serverless as well. Within serverless, there's a unique feature of Neon, which is scaling to zero. And what that means from the technology standpoint, we actually shut down the VM. So, we separate storage. Storage is one global low latency storage that lives in the cloud. And then every time you go and create a database, we'll launch compute in the VM of size X, but we know that size and you don't, and attach it to that storage. And as you drive the workload, we change X to Y or Z or whatever. We adjust the size. Now, if you go away and you don't touch the database for 5 minutes, we shut down the compute. Now, the question is, what happens when you come back and start querying the database? Well, we bring the compute back up, but that takes time. And generally, all serverless architectures fall into two categories. The ones that are truly serverless, shut it down to zero, but then the trade-off is you have a cold start problem. And then the rest of the systems are not truly serverless, so they slow burn compute, even if you're not using it. So they actually burn money. And then they have a choice of passing it down to the user or not. The difference in cost that we're seeing by doing some modeling is 5 times. So on our 100,000 database fleet, if we don't shut down to zero versus we do shut down to zero, the cost of AWS bill, the size of AWS bill is 5x difference. Now, our cold starts are currently about 3 to 5 seconds. And we're getting a lot of heat from the competition. They're like tweeting about us saying, oh, cold starts, they shut down to zero, cold starts are terrible and stuff like that. Just next week, we're going to roll out, and our cold starts will become around a second. And from there, we'll drive them down to half a second for sure, with some probability to 150 milliseconds, with some lower probability to 150 milliseconds. And at that point, it becomes unnoticeable. And so hopefully we'll be able to live in the best of both worlds, where we drive the economics and we pass those economics to the users. And we have, pretty much invisible cold starts, and we're getting closer to that vision that the database, just the URL, it's always available for you, and it scales up and down, and it costs you zero if you're not using it. But to answer your question, yes, it's that serverless promise that got us to engage with Vercel and engage with Guillermo. And Guillermo is also an angel investor into the company. And we're working very, very hard to become the best possible partner for Vercel.
Excellent. Yeah, this is, it's very opportunistic as well, because I don't think serverless has even hit its sort of inflection point. I think we had a lot of people trying the serverless sort of realm with tools and strategy. And I think the extremely ambitious for getting Postgres on serverless, I agree 100%. This is what made me really interested in just a product offering. I did want to touch base on the open source angle too as well, because you'd mentioned, what really struck me is that you went to committers in Postgres, and that's how you sort of fielded your initial team. But what's been the impact of being open source first with this sort of approach?
Yeah, we had a certain amount of debates. Internally, not that many, but people ask all the time, what's your license? Well, it's Apache. Well, what's your protection from somebody else, big, scary Amazon, or, replace Amazon with any other hyperscaler, taking your IP and rolling their own offering on your IP and the code that you spend a lot of time building. And the best answer, because intuitively I felt like that's no problem. We should just be Apache. And then I was talking to the CEO of Nutanix. He's the CEO of DevRev right now, but the founder is and ex-CEO of Nutanix. And he looked me in the eye and said, Nikita, the license is a rich man's question, and you're not. So make it Apache and forget about it. Just do excellent work. And if you do excellent work and the traffic does come and the threat that you are worried about does materialize, you can make that decision down the line. If you need to, you can relicense, which I don't want to, but it's still an option. You can also advance your cloud service ahead of where the open source bits are, which I think that is the Databricks strategy, or you can have additional services that are very useful to your users in addition to the crown jewel of the technology, kind of the core of the technology, which is storage. And that resonated super well, and so we just parked it. But I think the more I think about it, the more I think it's a feature, not a bug, to not only be open source, but to be open source with the most open license, which is Apache. And even more so, we are considering internally to not just open source the storage, to open source the control plane, which is absolutely unheard of in the world of database as a service. So if you look to any of our competitors, you will find that occasionally they are built on top of the open source backbone, but never the open source the control plane, because that's actually a lot of IP is in the orchestration of your cloud service. But I think we might open source the control plane as well.
Okay. And can you explain, so the orchestration is the control plane, for someone who's not building database tools?
Yeah. So that's actually Amazon's terminology, data plane, control plane.
Okay.
So data plane is your storage, and data plane in a way is your, the database engine itself, which is Postgres, right? And then control plane is when you log into the dashboard, into the console. Well, there's some amount of code for front end and back end of that console. Think about AWS dashboard. But then as you interact with the systems, you basically give the system tasks of, okay, go provision me a database here. And the system needs to go and spin this database up. In the serverless world, all the decisions of, hey, I want to increase the size of the database, decrease the size of the database, increase the size of compute, decrease the size of compute. move things around. That scheduler, distributed scheduler that runs on top of Kubernetes, all of that is control plane. And if you open source the control plane, then theoretically, with enough technical chops, you'll be able to take an arbitrary Kubernetes cluster and deploy all the Neon machinery into that Kubernetes cluster and run the service yourself. And so that's what we'll be exposing ourselves to. But I think in return, we're actually gaining stuff. We're gaining trust of our users. We're gaining trust that if something happens to Neon, the bits are out there. And we potentially will sign up on-prem partners down the line. Companies like VMware, we already signed up for Kona. So we're not closing the door to partners like this.
Cool. Yeah. And this is something that I personally, the way we structured the product I work on day to day is same question. Like we did go Apache as well for our license and then kept moving forward. I didn't get the same advice, but I just sort of watched a bunch of other projects do very similar approaches. So I was just like, let's just not overthink it.
Yeah.
Yeah. But the orchestration layer, the control plane, and I'm enticed. So I'm very excited to try Neons to start with some side projects. Definitely want to start shipping some stuff with it, get comfortable with it because the underlying technology being Postgres, so like it makes it very approachable to me. And I imagine everyone listening who also very familiar with Postgres, very approachable to them. So question to you is like, how do folks get started? What's a recommendation?
Look, it's trivial to get started. You go there, you authenticate with GitHub, and I assume you have a GitHub account. And then from there, you push a button that says create project. You name the project, press OK. And then 3 seconds later, you have Postgres and you have a connection string. So now just use Postgres through that connection string and build your app. There is a couple things that are new in addition to that. So basically, the first 5 minute experience is what I just described. You push a button, you can do it on this call, and you will have Postgres, and hopefully it will take you less than a minute to get onboarded to Neon. There are a couple more things which are different. In addition to the Postgres connection string that you can consume from, Python or Ruby on Rails over TCP, we offer a serverless driver that you can consume over REST API. So if you go and Google Neon serverless driver, it will have an instruction. So you can query Neon from your browser. You can query Neon from the Vercel Edge function or from Vercel serverless function. And then the other thing that's different is you can create branches. So if you need a dev environment for your production environment, at any point in time, you can go and say, hey, create branch, and that will create a full copy of your data and give you a separate URL, separate endpoint for you to query the database. And that's how you create an isolated environment for your project.
Okay, cool. Yeah. So thanks for sharing how folks can get started. It sounds pretty straightforward. So with that said, I'd love to get us over the picks. These are jam picks, things that keep us going, that we're jamming on. Could be tech related that keeps you up at night, or actually hopefully the good kind of keep you up at night, but also music, food related as well. But if you don't mind, I'll go first.
Yeah.
And I mentioned this in our prep call. Been messing around with LangChain. I actually sat in a workshop for it was like the On Deck Fellows. Some a bunch of founders have an organization, and it was one of their workshops. It was specifically on how to get started in LangChain, and it was like, once I saw someone implement it, I was like, oh, I get it. I totally understand what we're doing here. And the world, I know Neon's going to be shipping something pretty soon, but this world of doing semantic search and building your own chat GPT and training, not even training the model, but just keeping track of searches on top of searches and the result of searches that it built on top of better searches. Completely blown away, but I've got so many nifty ideas on what I want to do with it. So I won't share what my cool side project will be, but I've got a really cool side project around the data we have in open source, contributor data, and how to leverage LangChain. So I haven't seen anybody else pitch the same idea. So I'm actually looking forward to ship this in the next week or so. And then,
very cool.
Yeah, if we're lucky enough, it'll be on Hacker News. If not, you'll have to comb through Reddit and see where the post got missed. But yeah, LangChain, check it out. I'll pause and ask if you have any picks for us.
Let's see. The one that I've been looking lately is in the auth space, authentication. So I'm a huge fan of Clerk. And so do invite them to your podcast. I think they're doing very important work that is delivering on the promise of Auth0, but delivering it for the JavaScript and React world much better than Auth0 did. So that would be probably the first thing that comes to mind. There are a couple more smaller things, one of which is dark mode. And every developer tool should have a dark mode. And so Neon is going to have a dark mode. So I think on that one, that would be kind of the highlight.
Wow. I'm envious. We have actually not shipped our dark mode yet. We shipped a feature that actually is presented in dark mode that we'll ship next week, which is a different way how we present our data. But we haven't done dark mode because it was just like, it's one of those things that it's either do it at the beginning or like when you have the time, and we just never had the time.
Yeah, we're in that mode now where we catching all the corners. I want to call it dark corners, but they're actually light corners, and then we need to go and pay them into dark mode.
Yeah, you've got a very exciting launch happening that recording of the podcast for folks to take a look at. Why don't you explain that?
Yeah, so we have a launch coming in next week. We're very excited to introduce a few things to Neon. Now, Neon is a 2-year-old company, but we launched it last year about the same time. So the company is 1 year old on the market.
I didn't even know that. I was assuming this is around since like 2020 or something, but
no,
absolutely amazing.
In 2020, it wasn't even an idea. We started in 21, March 21. It was 3 guys and a dog. Actually, there was no dog. It was just the 3 guys and a slide deck. And we started working on that. And obviously, you need to build a service and you need to build the storage. And storage is, it's a pretty big project. And last year in July, at the same time, we were behind a wait list. So we had a few thousand people on the wait list. And then we started to onboard them, 100 by 100, and then learning how immature the system was. And then we just kept maturing the system. We officially invited everybody December 6th last year. And to give you some more stats, January 1st, we had just under 9,000 databases on the platform. And as of today, over 100,000 databases on the platform. So since January, we drove the number of databases, very, very high. So now we launched every quarter or so. And this time around, there is a number of things that I'm super excited about. I'm actually looking at the plan. So a lot of them are just reliability and performance. So we're going to improve our cold starts, as we talked about cold starts. And I say cold starts way too much. I don't even know what I say more, AI or cold starts more often. So,
well, in serverless, if anybody touches serverless, cold start is something you probably talk about a lot.
Correct. Yeah. And so we're going to improve our cold starts from 3 to 5 seconds, and specifically the P90s to about a second. And that's just the first step towards improving the cold starts. So I think cold starts were right now, they're just annoying. Once they're in the second range, they are still annoying, but a lot less. And then once they're going to be in the low 100 millisecond range, they hopefully will become unnoticeable. So the first thing that we're going to do is we're going to have improvements on the cold starts. And that's kind of unique to Neon. Classically, databases offer you a TCP connection. And the TCP connection is how you interact with the database. You go authenticate, and then you start establish a TCP connection to the database, start sending queries. Now, this works kind of less well in the web scale world. In the world of, okay, well, I have my app written mostly in JavaScript, and it has front-end, back-end database. But that backend starts to disappear, if you know what I mean. We're starting to live increasingly in the world of declarative backends, and then a lot of code is written in the browser. And specifically, this declarative backend doesn't necessarily run in a VM. So it can run in a serverless infrastructure. It can run in Cloudflare Edge functions, Vercel Edge functions, Vercel serverless functions. So it's hard for that backend to maintain a TCP connection anywhere. And so that's why we introduce this thing that we call Neon Serverless Driver. And that serverless driver gives you single, we have that today, but starting next week, that serverless driver will give you single-digit millisecond latency between an edge location and Neon, at least in the same region. So that's another thing that we'll be launching next week. We are launching our PG embedding extension.
Okay.
So if you're familiar with PG Vector it's a plugin to Postgres that allows you to do vector math.
Yeah.
And what people use it is kind of like an alternative to Pinecone to build memory to their large language models. Now, if you actually zoom in and look at the implementation of PG Vector, it uses an algorithm, an indexing algorithm and a search that's called IVF flat. But all these algorithms, they run a process called ANN, approximate nearest neighbor. Basically, given a vector, give me top however many vectors that are closest to that vector, to the input vector. And the reason you want to do that is because, you want to do a semantic search, right? You get embeddings out of OpenAI. OpenAI has a very cheap API for embeddings. And then you index your content, based on it per document or sometimes on it per paragraph, per snippet, whatever. You create those embeddings for them, put them in a vector database. And with PG Vector, Postgres becomes that vector database that can store vectors and that can run approximate nearest neighbor. And in PG Vector, you're using an IVF flat algorithm. Now, the complexity of that algorithm is square root of n.
Yeah.
And there are other algorithms, specifically HNSW, which is an alternative. The complexity of HNSW is log n.
Yeah.
And so as you start adding more and more vectors, log n becomes much smaller than square root of n. And so modern ANN implementations from like Google and Facebook, various libraries, they tend to use HNSW and not IVF flat. So we're going to launch a plugin that's called PG Embedding.
A Postgres plugin specifically, or is this a Neon?
Yeah, it's already out there. It's an open source repo. Of course, the license will be either Apache or Postgres license, but basically super permissive license. And it's an alternative to PG Vector on our basic benchmarks. And of course, it's benchmark specific. But we put like 1 million documents into the thing and compared the performance. So it gives you about 40 times faster performance on vector lookups on this approximate nearest neighbor. And the other thing that what they call it better recall. So recall is, the percentage is basically, how accurate that is, because it's approximate nearest neighbor, not nearest neighbor. And precise nearest neighbor is too expensive. So we need to basically scan the whole data set. But with an index, you can, compute approximate nearest neighbor. And approximate nearest neighbor algorithms always have this recall parameter. And the higher the recall, the slower they are. And when recall, I think, just want to be precise here with the definition of recall. But I think when recall is like 1, that means it has to be absolutely precise, 100% precise. And so recall is the number between 0 and 1.
Yeah.
It's a number between 0 and 1. If it's 1, you request 100% recall, and that's what makes algorithms slow. But if your recall is kind of reasonable, then they're much faster. But you, as a user of that, are okay with certain imperfections and imprecisions. Anyway, long story short, better recall, 40 times faster, implements HNSW. Basically, we're wrapping libHNSW into PG embedding. And so we'll introduce it to the world, and we'll offer it to the folks at the hackathon. About LangChain and the rise of PG Vector. But basically, just to repeat myself real quick, PG Vector implements IVF flat, which is an algorithm with a complexity square root of n. we're launching PG embedding. Same idea, the similarity search, open sourced under the Apache license, but the complexity is log n. So it's a much more performant algorithm. And if you have a million embeddings, so you should expect, about 40x improvement in speed on that algorithm compared to PG vector.
Very cool. Well, by the time this podcast comes out, this stuff will all be launched. So folks, check it out. Check out Neon as well. And Nikita, thanks for chatting with me and sharing updates on serverless Postgres and what you guys have accomplished. I'm extremely impressed.
Yeah, excited to be here. And we should talk again next year, same time. And then you will see how much we will have done.
For sure. And listeners, keep spreading the jam. That's all we have time for today. If you're interested in being a guest on the show, or if you'd like to suggest a topic, find us on Twitter @Jamstack Radio. This show is brought to you by Heavybit, the leading investor in developer-first startups. To learn more about Heavybit, visit heavybit.com.